Hello friends, welcome to the magical world of machine learning. Don't worry, it's not actual magic, though it sometimes feels like it. In simple terms, machine learning is when computers learn from data without being explicitly programmed. Or, in human terms, it's like teaching your pet dog to fetch the newspaper without ever saying a word, but using lots of treats, or in ML's case, data. So, if you are into AI, automation, or just want to sound super smart at parties, ML is your jam. Today, we are covering ML basics, types, examples, and deep diving into something many people fear, that is, statistical modeling. So, let's get started. So let's talk about the three main types of machine learning. That is supervised learning, unsupervised learning, and reinforcement learning. So let's understand supervised learning. Now imagine you are studying for an exam with an answer key. You learn from the labeled data, like teacher showing you the right answers. Means in this supervised learning, we have the things prepared for us. We just have to revise those things. We just have to understand those things. So that is why the labeled data here means the things which are already labeled or which are already in the categorized, sorted. So like that, some of the data is present over here. And based on that, that model is going to be trained. So that is why here we have labeled data in supervised learning. Like if we think of example, think of email spam filters. The model learns to recognize spam by looking at emails that have already been labeled as spam or not spam. Algorithms mostly used over here are like linear regression, decision tree, KNN, basically the usual suspects in the world of learning. These algorithms are used. Now what these algorithms are, how we are going to use these algorithms, and where these algorithms are being categorized, means they are also being categorized into some of the divisions. So we are going to understand those things also. Okay, so for right now, just understand that if we are going to go with the supervised learning, or we have some of the labeled data, then we are going to use these kinds of algorithms to build our models. So what are the algorithms? That are linear regression, decision trees, KNN, basically. Okay, now let's come to the unsupervised learning. Now as by the name only we can understand that in the supervised learning we have some of the labeled data, but here there is no labeled data. Okay, the model is given data without labeled. Okay, now imagine you are thrown into a mystery novel with no clues, no answers, no help, just a big puzzle to solve. How will you feel, right? You are not having any clue, you are not having any answer, no connection with anything. So that will be the difficult task, right? But once you learn it, you will understand those things too properly, right? For example, okay, ever wondered how Netflix knows what you like? It's using unsupervised learning for things like customer segmentation or market basket analysis. Now, what this market basket analysis is, that is also I'll explain. Okay. In this unsupervised learning, the algorithms which we used mostly are k-means, hierarchical clustering, no labels, just data trying to make sense of itself. Okay, I'll quickly tell you what this market basket analysis. Okay, now as we have took this in our example, market basket analysis means what happens. Okay, if you are going for shopping, okay, let's consider you are going for Star Bazaar, DMart, wherever you want. Okay, there, have you ever observed that how the things are kept? If we are buying any of the phone, okay, let's consider we have bought a phone, then related to it, like headphones will be shown, chargers and any other covers like that, right? Which means these things are connected to that thing which we are buying. So that is known as market basket analysis. Okay, nice marketing strategy, right? Now let's move to the reinforcement learning. Okay, This one's like training a toddler. You give them a toy, they play with it, sometimes messes up, and either gets rewarded or scolded. Hopefully, with love though. Example, if we take of it, then think of self-driving cars or those cheeky bots in the video games that learns from every oops moment. Here we don't have any like trainer or label data, unlabeled data. Okay, here what we have to do, here we just have a vision, we have to follow that. If we are doing correct, like as we were thinking of it as toddler, right? So parents will give us reward or we will be get scoldings. So like that, if we are getting scoldings, we are not going to do that. If we are getting rewards, we will move with that only. So like that, machine learns by itself only, by working out. So here the algorithms used are like Q learning, deep Q networks. It's the toddler learning through trial and error, okay? So what's your ML personality? Are you a label lover, a lone explorer, or a reward chaser? Let me know in the comments. Now let's understand some real life examples of machine learning. Okay, so let's play this quickly a game, okay? You have to guess who's using machine learning in this. So Netflix recommending that new series you just can't stop watching. Yep, ML in action. So next, Google Maps yelling, take a U-turn. What it would be? Of course, that's ML2. Your credit card sending out a fraud alert. Yes, you guessed it right, ML. Your phone unlocking with just your face. Magic? Nah, ML at work. So if something smart is happening on your device, machine learning is probably the one behind the curtain pulling the strings. Like we have seen those puppet shows, right? Those puppets have been dancing, doing whatever their magics are, but it's not the actual magic. The one who is handling their strings is behind it. So here also machine learning is behind this, and it is pulling the strings, and then these things are working. So now let's understand how ML workflow is. We'll understand this by a minute chart. Okay, so here is that. So let's get behind the scenes and see how machine learning actually works. Think of it like baking a cake, okay? But with Python instead of eggs. So here's the process. Our first step will be, or we can say that machine learning's first step will be problem definition. Of course, it is the beginning step, and everyone, whenever we are doing any of the thing, we should understand what is a motto behind it, what is the thing we have to achieve when it, right? So here first is problem definition. Here we have to understand what's the goal. Predict prices, detect cats, save the world, whatever it is. We start with a clear question. Always questions are not bad, okay? We should ask questions. So if you have any questions, you can also ask me in the comments. Okay, next step is data collection and cleaning. Now, as machine learning works when it is being given some of the data. So data is we need data. So data collection and cleaning it are the important steps. And this also takes most of the time, okay? Data collection, cleaning the data, exploratory data analysis, these things takes a lot of time. Okay, so collect your data and then clean it up. Think of this as making sure there's no flour spilled before you start baking. Now, as we are considering this as baking, so I'm telling the things with that explanation only, with that example only, okay? So keep in the mind, just think like how is the workflow going, okay? First, now as we know, we have to, first is problem definition. So here we understood that we have to make a cake, right? Next is we should see that our place where we are going to make the cake is clean, the flour spilled or any other thing that is not needed are kept on the kitchen like that. Next is exploratory data analysis, EDA. Now, you play detective. You look at your data for hidden patterns, outliers, and maybe a few plots, twists, like in the serials. No, not like that. So we have to understand our data in exploratory data analysis. We have to when we know our problem definition, so we have to understand what are the required things, if anything that is outlier, what is hidden patterns, and those all things. Now you are very much familiar with that, right? We have covered these things in a Python series also, as well as in statistics also. So we have to find those hidden patterns, any of the trends, anything that is not working normal. Like if considering with the example of a baking, we'll think that if we have the amount of flour, if we have the amount of sugar, eggs, all those required things are there, and they are in the proper format or proper amount, we can see. Okay. Next is feature engineering. Now pick the right ingredient. Sometimes you might even invent a few of your own, right? That happens the things. Like if we think now this in our recipe book, one of the thing is not shown, but we want to add. Like if it is our favorite ingredient, then we want to add it, or we want to add. They have told the little amount of sugar, and we want it extra sweet. So we are adding some of the things by our own only. So that thing comes in this feature engineering. Okay. Next is model selection and training. Now here, when we were discussing about unsupervised, supervised learning and reinforcement learning, there I told that some of the algorithms are there, right? So here there are different types of algorithms present. Now it's our choice, or it's our thing that which algorithm we should choose for our model training. Okay. So that is said as model selection and training. Now time to pick your model. It's like choosing a baking recipe. Then you let the model study before the big test. Now if you are like, okay, while preparing for the exam, if a math paper is there, okay, on the next day we are having a maths exam, okay, and we are preparing for the science. So this is too out of syllabus, right? That is not in the correct flow, right? So we need to choose the right syllabus, right recipe, or whatever you can say in this, right study before our exam, okay, or also right subject before our exam. If not, then you can also understand what will be the result, right, in the end. Next step is going to be model evaluation. Now we have built a model, okay, we have trained it, we have built it, but is it correct? Now this question mark, we have to do experiments on that, and then we can give the final results, right? So model evaluation, test your model. If it's good, great. If not, you have to go back to the drawing board or the oven. Okay. Before serving others that cake, we will take one of the bite and taste it, and then understand it by ourselves only that we should serve it or not, right? Then if it is correct, then we have to what we are going to do is, if not, then we are going to the exploratory data analysis and checking what is being not correct, okay, or even we are starting it from the beginning. So that is it. And if it is good, then what we have to do is we have to deploy it. Finally, your ship is out into the world, ready for action. That is the process in the deployment. And behind the scenes, what it does, like it's need for problem definition, data cleaning, data collection. Now it depends how we are going to clean the data, from where we are going to collect the data, then how we are going to find the patterns, insights, trends, anything that is. Then if we want to make any person understand that data, then we need visualizations things, right? Then visualization thing is done, then feature engineering is there, machine learning comes into action. Okay, then we have to train the model, we have to do prepare many of the tests, and then that model has to pass those all tests, right? All, or at least 90% test it has to pass. Okay, then model selection training is done, evaluation is there, testing model is done, then we need to deploy it. So it has to pass many levels, right? So machine learning, it's like baking, but with more math and fewer cupcakes. Now next we are going to learn about statistical modeling. Now let's begin with the basics, okay? What is statistical modeling? It's the process of using math to explain how things work in real world. Think of it as taking a messy situation and turning it into something understandable with structure. Like for example, if You are curious about how coffee intakes affects your mood on Monday. We have all been there, right? Statistical modeling helps you figure out by finding patterns in the data. Now, once we have understood statistical modeling, we are going to understand it in the deep when we will compare this with the ML model. Okay, there are different models present, like statistical modelings are categorized different and machine learning models are categorized different. So we will understand that also. There you'll understand this in the deep. For right now, what we are going to do is we will understand now what is population versus sample. Now that we know what statistical modeling is, let's understand the difference between population and sample. A population refers to the entire group you are interested in studying. It's like considering every single person in the world who drinks coffee. Now this, if we are understanding data, okay, these are the different kinds of data types not, but data, how we are going to take data for the modeling. Okay, now we have this population, there are many number of peoples over there. Okay, from them we are only going to take 4 to 5 peoples, like that. So, and that will be considered as sample. So we should take population or we should take sample, that we are going to understand. So a population refers to the entire group you are interested in studying. Okay, however, studying every single person in the world would take a lifetime, right? So instead we use a sample, a smaller manageable group that reflects the population. It's like choosing 100 coffee drinkers to represent everyone. Like even when we are playing any of the team game, okay, let's consider cricket only. Okay, there we have the captain. Okay, so that captain knows everyone's habits, right? His team, he should know, he should have the knowledge of his team, like which player is good at what thing, which player is good at anything, like that, who gets easily angry, who is better calm person, who should be played where, right? He knows everything. So we just take the captains of 4 to 5 teams and we just ask him the things, and then most of the information we get from that also. So that is why the sample is there. Okay, so we use sample, manageable group that reflects the population. So it's like choosing 100 coffee drinkers to represent everyone. Next we have this descriptive stats and inferential stats. Now this will be very rude if you have not watched my previous videos. We have covered on statistics 2 to 3 videos. Okay, so in that I have explained this descriptive statistics in detail, whereas inferential statistics in detail. So I'm not going to explain much about it, but still let's talk a little bit about it. So let's talk about 2 important types of statistics, that is descriptive stats and inferential stats. Okay, so descriptive stats is all about summarizing and describing what's happening. Imagine you're looking at a chart showing how much coffee people are drinking and simply describing the trends. Whereas inferential statistics, what happens? It takes a step further. It's about making predictions. It's about making predictions or drawing conclusions. Like for example, after analyzing the coffee data, you might predict that people who drink coffee are likely to feel more energized on Mondays. That's making an educated guess based on that data, right? I prefer you all to follow the series, okay, because that is why only you are going to understand the things. Now, as I have explained descriptive and inferential stats in the previous videos only, so it will be very good if you are going to watch those videos. Now, next let's learn about types of statistical models we have. Now, let's take a closer look at the types of statistical models we use to make these predictions. First we have in that is linear regression. This model is used when we want to predict a numerical value. For example, predicting someone's salary based on years of experience. A simple straight line relationship, right? The next is logistic regression. See, now okay, keep that aside for logistic regression for a minute. Okay, now we are just discussing about this models. Okay, but one by one we have to understand each, we have to build a model on each of the regression, then we are going to understand it in detail. Okay, so that is why the most important are linear regression and logistic regressions. Okay, linear regression and logistic regression, and that is only mostly used. Okay, this ANOVA and time series models we should know, that is why I'm telling. Okay, so here we are just going to understand the definition of it, theoretical part, and in the upcoming videos we are going to build one by one models. But now what happens is people want accuracy. Okay, they don't want how detailed it is or how what the behind the scenes is going. Okay, they want the output, they want the accuracy. So that is why the ML models come in over there. Okay, so ML's models, most of the task is, we will understand that its task is like it should give accurate results. So here what happens in this linear and logistic regressions, what happens means like statistical modeling, what happens, it tells us most of the things that what is behind the scenes going on. We'll learn about this models also. Okay, so what is the logistic regression? If we need to predict a category, like whether it will rain tomorrow, yes or no. So this is category, right? Yes or no. We have the data into categorical form, right? Means like this is non-numerical data, right? So that is why yes or no, 0 1 0 1 is not, but like that conditions are there, then we are going with this logistic regression. So there we use logistic regression. Okay, it gives us a yes no answer based on the data. So next is we have that is ANOVA. Sometimes we need to compare multiple groups. So let's say we want to compare with ice cream flavor is most popular. So let's say we want to compare which ice cream flavor is most popular. So ANOVA helps us compare all the flavors at once, find the winner. So time series model, what happens in this? These are used when we want to predict future values based on past data. It's like forecasting the weather by looking at past weather patterns. So what are the assumptions in modeling? Like what are the faiths, beliefs in the while modeling? Okay. To make sure our statistical models are solid, we need to consider some assumptions. Think of them as a foundation of a good model. So these are assumptions, let's discuss them. Okay. First is linearity. The relationship between variables should be linear, meaning a straight line connection. If it's too chaotic, the model will struggle. Okay, so it should follow linearity. Next is independence. Each data point should be independent of others. Like imagine your data points are free agents. Okay, not influencing each other too much, like that. Next is equal variance. Now your data should have consistent spread or variability. It's like making sure everyone in class is contributing equally, not just a few people dominating the conversation. Okay. Next is normality. For many models to work well, your data should follow a bell curve. This means most values are centered around an average. Now what this average is, what this bell curve is, that also I have explained in detail. Okay, so this means, so it should follow the bell shaped curve. Okay, and most of the means are centered around the average and fewer values are at the extremes. So there are small concepts that we should know. Okay, like multicollinearity is, what are outliers and what is overfitting, so that quickly understand those things. These we just need to know these things. Okay, before we are going with the actual functional part, we should be clear with our theories. That is why I'm explaining these things we are going to need, and if anything that is required at that time, that also I'll explain, but this we should have the knowledge before moving to the machine learning. Okay, before this is only machine learning, but we should have these things knowledge, and then we are going to go with the functional part also. So let's quickly talk about a few troublemakers in statistical modeling. Okay, that is this multicollinearity. This happens when your input variables are too similar to each other. It's like having two friends who constantly agree on everything. The model can't decide who's actually influencing the results, right? That's where this multicollinearity comes. Next is outliers. They should lie out only. Okay. These are data points that stand out like sore thumbs. Think of them as the wildcards of the dataset. If you don't handle them, they might throw your model out of track. So that is why we need to handle these outliers, and there always these outliers comes. Next is overfitting. This occurs when your model becomes too good at memorizing the training data but fails when to apply to a new data. Most of us have faced the situation, right? Whenever we have something that is fully prepared in front of us, we try to play in that only, but we don't try it ourselves. But once if we try it ourselves, then most of the things becomes easy for us. So this overfitting occurs when your model becomes too good at memorizing the training data only but fails when to apply it to a new data. Now it's like memorizing the answers to practice problems but freezing on the actual test. In exams these things happen, right? If we have just memorized what the answers are given by our teachers or any of the books, guys, those things, then in the actual exam we don't remember, mesmerize it all the things accurately, right? If we have understood the things clearly, then we can write the answers on by own also. Okay, now we from the starting we are discussing about the statistical modeling and everything, its factors, its assumptions and all, which are the algorithms used in this. But now let's discuss about why the statistical modeling. So why we care about all the statistical modeling? Simple. It helps us explain why things happen, not just what happens. When you understand why something happens, you can predict it better next time. Now, let's say you are analyzing sales data, okay? Understanding the factors that drive sales growth means you can take steps to improve those factors in the future. In other words, statistical modeling helps you to make better decisions. Now come the most important part, okay? We should understand what statistical modeling is and what machine learning models are, okay? So, comparison between them. Statistical models versus machine learning models. It's like comparing Sherlock Holmes with Iron Man, all in one logic and dedication. The other, all is one logic and dedication. The other, gadgets, data, and boom, predictions. So, what are statistical models? Okay, so let's start with the old school legend, that is, statistical models. These are like the wise teachers. They love to explain stuff like, why is the variable important? Let me draw a graph and talk for 2 hours, like that. They explain the things in too much detail. Statistical model is a mathematical equation that explain relationship between variables. Let's say you want to know if studying more helps you score better. Stat model says, okay, I'll check how study hours affect your marks. Here's a line and here's R squared. Boom, explained. But here's the catch. They come with conditions. Like they'll say, I'll help you only if your data is normal, linear, independent, and the stars align. Just kidding, but not really. It should follow linearity. Whenever we are passing the data, it should follow linearity, no multicollinearity, constant variance, and normally distributed errors. Basically, if your data misbehaves, the stat model goes. Not my job, bro. Now let's talk about ML models. Now enter the cool kids machine learning models. These models don't care about any assumptions. They just want to predict and predict well. Like ML model learns patterns from the data to make predictions. They don't bother much with why. They focus on what. Think of them as magicians. You gave them a rabbit, that is data, and then they gave you a hat, that is prediction. And you like, how? ML says, don't worry about it. Here, accuracy is everything. ML models are all about accuracy. They've used when we have got a tons of features, messy data, and want a superior performance. Want to predict which customer might leave your platform? So if you are working anywhere and you want to predict which customer might leave your platform, XGBoost says, I got you fam. 20,000 features, 5 million rows, and ML just flexes. Now, what we will do is we will just understand it, means like let's break it down with the real life examples. Okay, so I'll tell these are the tasks. Okay, so I'll tell these tasks and you have to which model we should go with, that we will discuss about. So predicting salary from years of experience. I have told this example when we were learning that statistical modeling also. Okay, so stat model will be there, and which algorithm we are going to use in this, that is linear regression. Next is detecting fraud in banking data. So we should go with the ML model over here, and model will be like random forest. Don't worry by hearing the names of these models. Okay, this random forest is ML model. Okay, we have not discussed that, right? Because we have mostly discussed statistical modeling, because our next topic is also going to be that only, statistical modeling only, like linear regression and logistic regression. We will focus on that. So understanding how each factor affects health. Here also we are going with the stat model, and in this, now what type of data will be there? When we look at the data, we can understand the things, right? So that is why stat model. Here we are going to go with the logistic regression model. Now recommending movies. Now as we were discussing about the Netflix example, so which model it will be? It will be ML model, and here collaborative filtering will be used. Okay, can be used. Okay, it if you have any different ideas, then you can go with that also. So okay, stat models, it explains the things in detail, and ML models, it directly predicts. It doesn't care about if who will understand him or not, who will think like how it has worked or not, like that. Like most of our generation is like this, right? Okay. Now, how to choose? So when do we use which? If you want to understand relationship, explain causes, or your boss says, explain this to the client, then go with the statistical model. If you want high accuracy, lots of features, and don't care about why, then just what works, then go with the machine learning. Or better yet, use both. Use stats to understand, ML to boost the performance. So both are legends in their own way, right? So we have to choose the things on our data, our goal, and our audience. And that's a wrap up for today's machine learning intro. I know, your brains are probably overloaded right now. But hey, you survived your first lesson. So don't worry if you didn't catch everything today. We'll go slow and steady, and before you know it, you'll be a machine learning pro. Make sure to hit that like button if you are excited about the journey ahead. And subscribe so you won't miss out on any future videos. Trust me, there's a lot of fun coming your way. Till next time, keep learning, keep experimenting, and remember, even robots needs a coffee.